Good morning. Thank you for registering for the webinar on what's new in ArcGIS Pro for Water Resource Program. We have a full house and we're quite excited to share the insights and updates that we have curated for you. I'll quickly introduce the speakers. Mr. Suneet Manjavkar, Industry Head Water at Esri India, and Ms. Neha Sagar, Manager Pre-Sales at Esri India. I would encourage everybody to put their questions that you might have in the Q&A or the chat box that you see on the right-hand side of your window. We will take up the Q&A during the webinar and some of the questions we'll try and take towards the end of the webinar. And I think without taking much time, I would like to pass to Suneet to set the context of the webinar and take you through it. Thank you.
Thank you, Rajiv. And very fresh morning to all distinguished participants, industry colleagues, professors, and the engineers from various water resource departments. Thank you for taking your time to attend and witness what's new in ArcGIS Pro for Water Resource Program. Myself, Suneet Manjavkar. I work for Esri India in a water domain. Yes, when technology succeeds, when it scales it up for the purpose, it has future for today and tomorrow. And current future of water management is in a spatial, predictive, and intelligent way. Map is normally often being called as a language of GIS, which is primarily a communication tool, visualization tool for the complex data, which is spatially sparse. At the same time, it helps us how this scaling up the technology, bringing the purpose, and that's what the GIS is bringing in. So GIS is moving beyond the map, it's advancing rapidly. It's become the interactive data-driven system with a modern 3D real-time, near real-time content for the users, see the do analytics, and also embrace the new challenges of system of water resources, and also bringing in the technology of artificial intelligence in the form of GOI. GIS offers to India very unique opportunity. It shifts from the fragmented and reactive water management to the integrated and informed governance, which is actually transforming our water security layer scenario by economically viable, environmentally sustainable, and the socially equitable scenario with this kind of coordinated and integrated water resource management. Now GIS is no longer remain the mapping and visualization analysis tool, but it's become the platform of enterprise level. It's federated in a structure with a cutting edge remote sensing technology, bringing a lot of near real-time data, and which is get curated on your desktops under at planning and design stages, which integrates various external systems like ERP, SCADA, IoT with standard APIs and services, and could able to identify the interventions for today and tomorrow. And that's what the informing and articulation of interventions is happening. As it is moving, it's advancing. The GIS has also taken leap from normal vanilla GIS to the engineering GIS, and where the ArcHydro as shaping up as a tool for water resource program. GIS for hydro modeling cycle. It is for both surface water as well as groundwater. What you're seeing today is a tool which is having more than 120 features, tools, functionality, which is you can use for the visualization, integrate the hydraulic modeling, bringing the data from the various aspects to do the flood simulations, your erosion assessment, sedimentation assessment, and finally creating the network which is required for the interventions level. And once you have this platform for tomorrow, what it's bringing to the table is a unified data model. and which could reflected in a State Water Informatics Center. This is integrating the external source of data in RTDAS integrations of SCADA with open services with standard API. You can see the unified data management, which bring the near real-time insight with a data consistency as well as enterprise-wide applications. And this is what can be reflected on the State Water Informatics. You have the data of rainfall on the top. You can see meteorological data, API integration, land use pattern, as well as interventions. At the same time, the instrumentation has the battery. That battery life also can be further monitored on top of it. As this enterprise GIS unifies the platform to centrally manage and secure and share this geospatial data across the organization, this unified data brings you the data consistency, and that's what the prime motive, and also bringing the data from the field. So isn't it really exciting that when you have this kind of tool to create your own State Water Informatics Center as part of your what this is offering, we would like to put it forward to you. There is a specific tool called ArcHydro, primarily, could able to building and bringing this insight for tomorrow. And that's what I would like to take it. And so what's new in ArcGIS Pro? I'm excited to share with you, learn from you. And that's what I would like to request Neha Shirsagar, my colleague, to take you to the what's new there. What is the scalable coordinated environment within the ArcGIS Pro, which would help and curate the solutions for tomorrow for our water security of the nations, water security of the state, and bringing the social equitability at the level where we stand to contribute. So over to you, Neha.
Thank you, Sunit. I'm Neha Shirsagar, manager at Esri India. I'm excited to walk through of what's new in ArcGIS Pro. So Sunit have already set up the ground, and I'll move towards the demonstration part. You know, it's exciting, right? So I'll directly go to the ArcGIS Pro tabs. Here I'm showing the ArcGIS Pro 3.5 version, and the latest version you can download from the update scenarios. I click on the new, you will get map, global scene, local scene, catalog, everything in one glance. Clicking on open, you will get the information related to the historic scenarios. And I'm clicking on portal where you can integrate enterprise with ArcGIS Pro version. So you can publish the data to create the RTDAS dashboards and all. Here I'm going to the lands licensing tab. I'll show the basics, standard and advanced license, which shows the capability of the user specific scenarios, like basics, which gives you the information related to just viewing the data. Standard will just give the basic scenario of editing, and advanced shows all the extensions as the bundle values, like data interoperability, image processing, spatial analyst, everything which will be helpful for water resource. I'll go to the option here. You can customize the ArcGIS Pro according to the user specific scenario, like coloring, display, editing, geostatistical processing, geoprocessing, indexing, language changing according to the user specific case. And you will go with the model builder, which is the newest capability, and versioning even. So basically you will get everything in one glance, and you can customize according to the user specific situations. I'll just click on cancel, and we'll go to the setting tab. And I'm just showing a add-in manager, which will be helpful for water resource like ArcHydro Ground as a third-party tool, ArcSWIC to be added into the target version of 3.0 like 3, and ArcHydro tools. Even the target version is 3, like the one which is newly advancement. I'll move towards about the one which I have just shown, like the 3.5 version. Now the learning one. So individuals can learn everything from ArcGIS Pro in one glance, like the learning quick start tutorials, like making the layout, creating the data, exporting the data, symbology, geoprocessing tools, mapping and visualization, migrating the scenarios, and everything in one glance. If you go further down, I'm just clicking on down, you will get the tutorial series even, like mapping and visualization I've just said, even analysis and modeling. So everything related to the analysis like the geoprocessing tool, rasterization, vectorization, adding the living atlas platform data into the ArcGIS Pro. Clicking on more tools, tutorials, you will get everything as a demonstration point of views. Like the quick start tutorials, you will see like this. Everything has been explained in the documents as help document where we have version specific situations like 3.4, 3.5 and 3.6. I'll move towards what's new, like ArcHydro, what exactly provides as GIS for hydrology and hydraulics. So we comprehensively have 5 demonstrations to be shown, like ArcHydro for feature extraction as data refinement, linear referencing. So after feature has been extracted, how the linear referencing will be gone for the dynamic segmentation, how the data is actually added, and how RAS commander as a plugin. So the outcomes from the RAS can be added, can be integrated in the ArcGIS Pro networks to have the further analysis and the scenarios. Fourth will be the erosion toolsets, and fifth will be a 3D visualization. I know you will be interested in 3D part. I'll go to the first demonstration as delineation and hydrofeature extractions. So basically, what exactly the drainage delineation stands for. Previous hydrology tools have the you need to add some digital elevation model, create a statistical analysis, go with the catchments, basin analysis, and the field accumulation and all. So everything you customize, everything needs to be added in a first way. Like one person at a time, clicking on the one tool, you need to go with the second thing, and now need to create the EDH one, like the elevation derived hydrographies and all. Now, ArcHydro provides the exciting tool as dendritic terrain from unknown stream location. What exactly you need to be done? Just need to give the data related to them. Everything can be done with the ArcHydro tools from their sets, like creation of the catchment, creation of the flow direction, accumulation, stream values, and drainage patterns, raster and vector catchment streams, everything in one glance. So I'm showing the outcomes. So you will see the scenario of 2 meters, 30 meters, everything in one glance. So it creates the dendritic terrains and it will actually generate the streams. Second will be hydrofeature extraction. So here you will see ArcHydro have the geoprocessing tools for downloading the data even, like downloading the DEM as a study area, like region of interest, like individuals can give their region of interest and they can even download the data and download the DEMs from there. Even after downloading the data, you can create the platform as IDF curves. That IDF curve will be actually used for the atlas for the precipitations. So atlas 14 will be the one which ArcHydro provides for duration and the specific precipitation scenarios for the terrain as the constant values. Even you have the facilities of taking the data for the region of interest and even calculate the land use parameters. The land use data can be directly downloaded from the process as the geoprocessing tools. Final will be the outcomes from the land use and the roughness. Everything can be added as an input to create the roughness index of the streams. And final will be the outcomes from the roughness index will be added to the stream to refine the stream into the scenarios. Final will be, it will be helpful for flood stimulation, for the refinement of the stream, and even the RAS commander values. What was the second demonstration as linear referencing and dynamic segmentation? So what exactly linear referencing does? So it will actually creates the hydro ID and the mainstream IDs. Like linear features, like you will see the roads, riverine situation, cross sections, age lines, and everything in one glance. So previously also we have the linear referencing tools like the data which is shown in the blue colors, which actually shows the previous version of hydrology tools. The tools which are showing the assign mainstream ID, create linear events and AH events and all. So these are the newly advancement tools which ArcHydro provides. Previously it was even the ArcHydro which shows the events were related to mainstream ID, the one which I have just said. creation of the events like point, line, polygons, and to create the junctions, intersections, so people can go with the vectorized scenario and they can generate the routes for utility programs. Everything is written in white paper of ArcHydro tools for linear referencing. We'll move towards the demonstration part. Here you will get the data related to the outcomes as the mainstream ID, length, and even the stream flows and the terrain IDs even. I'm clicking on hydro junction. You will get, I'm just clicking out. And sec, I'll go to the drainage point and we'll just click on the hydro junction. We'll give the F type of the scenario like stream confluence, AH types, details, and even the hydro scenarios. I'll open the drainage event points, which shows drainage ID and even junction ID, which is showing the mainstream ID. Clicking on one of the tab will show the confluence and even the hydro node IDs to get the next downstream scenarios. So it will be helpful for junctions and even it will be helpful for utility networks to create A junctions to B junctions, how the water will flow accordingly. We'll move towards the third demonstration, like RAS Commander. So RAS Commander is the plugin of ArcGIS Pro, which will be helpful for importing the HECRAS data to ArcGIS Pro environment. How to download the ArcHydro RAS Commander. So we have some demonstration like the RAS Commando demonstration. And here you can see whatever the data which can be added as 1D geometry, 2D geometry, direct data access, results in values, pipeline, nodes, and everything you can add it in one glance. We will be sending this link at the end of the webinar to download the RAS Commander. And you can just explore in ArcHydro Pro newest version. What exactly the RAS Commander? So RAS Commander, which shows the HECRAS newly data added as the data access from RAS as a values to import into the ArcHydro parameter as an ArcHydro tools, like the separate toolbox which generates 1D and 2D geometry and just create the WSC like water surface elevation and velocity tools in one glance. I'm showing the tool sets of RAS Commander. Like we have data import tools as subtypes. Second is project management. And third is like outcomes on the RAS is actually added into the resulting scenarios. Like first will be the loading of the 1D data. 1D stands for the linear features like line, like the one which is riverine situation, bank line, edge line, 1D structure, cross sections. 2D will states with the point and the polygon scenario, like the mesh creation, brick line, 2D data, pipeline, node, junctions, and everything in one glance. Final will be the data as 2D results to be added as a summary layers for WSC, like the one which I've just said, like the water surface elevation, and the velocity creation to be added into the new geodatabase for the further processing in our ArcHydro environment. We'll move towards the demonstration of importing of the data. Here I'm just going with the RAS Commander tool, loading the data, adding the HDF file. HDF actually, and you will just get the data. You just individuals can click whatever the things they want. Like I have just clicked on all the things related to age, 1D structure, cross section. Clicking on run, you will get, I'll just show even the inputs. So here you will get the related to raster from the data which is coming from the RAS. And the outcomes are structured 1D, age line, bank lines, whatever the data which I have selected can be shown in a RAS Commander. Now I'll move towards the second parameters and adding the 2D geometry. Geometry is actually I just shown and I just said like related to the point, mesh, everything in one class. Clicking on the HDF file. I'm just clicking on 2D break lines, conduit, conditions line, mesh parameters, faces, polygons, conduits, nodes, and networks. So outcomes will be the newest value which is added into the GDP format. And clicking on run will be getting the outcomes related to the 2D geometry values, which is pipeline, conduits, mesh, parameters, and even, the break lines and all. Interesting, right? I'll move towards the third one, is project management part, like importing the data, organizing the data, and the resultant. So organized part will move. So here I'm just taking the data as the project is already running. So the data is actually coming from the directory or the project folders and or the HDF file. And I'm just clicking on the done will give the GDB format as 1D, 2D, and the data format. So everything can be organized, can be shown in one glance for the RAS environment towards the ArcGIS Pro environment. Let it run. I'll move towards the loading of the 2D result summary. So the third one is like clicking on RAS commander, clicking on the resultant tabs like which generates the maximum WSC and maximum velocity. I'll just click on it. We'll keep the data as an HTF format from the data coming from the RAS. Clicking on OK. And I'm just clicking on the result parameters to be shown as WSC and the velocity. I will just even use second, I'm just showing the data related to this. Outcomes can be in a GDB format. Clicking on run will be shown towards the final value as maximum velocity and maximum speed. So you can see the scenario related to the maximum velocity as an attribute table. You can see the negative velocity is showing here and even the phase IDs. The fourth demo, erosion toolsets. Erosion works on Russell framework. Russell, you must be knowing about the Russell. Like previously it was USL, like Universal Soil Loss Equation. And the newest version of ArcHydro has been added with revised version, so Russell. So there has been many tutorials and the video tutorials which are actually added with the series GitHub framework for erosion toolsets. You can get the scenario related to video tutorials. So individuals can directly refer this format. I'm just showing this. We have 8 currently tutorials and currently 8 steps to create the erosion toolsets. Outcomes as actually just shown in the white paper. We'll move towards the demonstration part of erosion. So I have ArcHydro, HNH modeling, and going towards erosion, I'll characterize the dam. Just input needed is the characterization of the dam inputs. I'll just show the input dam creates the outcomes as the flat terrain as raster and flat terrain as polygon outcomes and the landform creation too. Clicking on run, you will get the information related to the characterization of the dam. And the flat polygons where we can see the maximum possibility of accumulation of water scenarios. I'll just show the scenario related to the water case. So this will be the ponds and even the structure which is low lying areas. Clicking on the second one, which is giving the processing of the erosion tools. Like I'm just giving the data related to dam only, giving the threshold and we'll give the data related to parameters values, the square meter, and I'm giving the polygon layers for the sync. Clicking on run, you will get the information related to the data dam processing. Third type is like the input from second process will be added as an input of the third one. So input will be the dam as the main parameter and the slope and the outcomes and all. Clicking on the run, you will get the information related to the LS raster creation. So all the 8 processes are there. You have to be a little patient for this. I'll not show all 8, but I'm just showing the procedural aspect. Clicking on this, you will get the pop-ups info. I'll just move towards the parameter like the vegetation cover creations, and you will see scenario related to the heading of the data as them, adding the scenario related to the land use land cover parameter. You can just need to add the land cover parameters and the lookup tables. So the video tutorial is already demonstrated in Esri's land cover platforms as erosion tools. Clicking on land. So this actually creates the soil erodibility rasters, like clicking on the input rasters, getting the data, adding the soils, infos, and you will just get the erodibility. Outcomes from the erodibility as it as an input from this one. So it's that simple. You just need to add the input, get the outputs, outcomes from the previous one will be added as a cycle of the input of the newest one, and the cycle process till the 8th one to get the summary results into the format. I'll just go towards the 5th one. This is the last 3D flood simulation. Just take the information related to the hand outcomes like height above the nearest drainage to create the flood depth scenarios for the raster and the vector sense. Like we can just generate the raster and vector in one glance. So people can use according to their usability, according to their topic of interest. If they want to have the raster, if they want to have the vector, something anyhow. I'll just take this as 5, 6, anything. You can just give the depth parameter. I'm just changing the data from 10 to 5 to create the depth at 5 meters. Copying this, I'll add to the raster because I want the same name to be added to the raster even to have the clicking on run, you will get the information related to. I already ran the model firstly. I'm just showing the outcomes for 1, 2, 3, 4, 5 till 10. So I'm just showing the information related to everything in one glance, like 5 meter resolution. So everything I've added into the one set as the mosaic parameter to 1 meter resolution till 5th meter, like 5 meter resolution scenario as depth values. We'll move towards scene, like the 3D demonstration of flood parameters, which shows the inundation of how the impact will be shown. Here you can customize your rainfall and your infiltration, your evapotranspiration data and all. So currently I can just customize according to the configuration tabs and it will actually show the inundation values. You can just see the start and help. The simulation tab will be shown here in the ribbon values. We have the demonstration of global one even. You will get the information related to what exactly the Zuri's flood has looked like. So previously it was a basic scenario and we are actually showing the impact assessment of how this flood will impact to the particular area, particular shows and all. This will be the length, the measurement, like what exactly the buffer distance to be added to create the flood situation scenarios and the impact assessment for the specific potential prone areas for the scenarios. I'll move towards the next one as this 3D scene. You can see the beautiful scene as outcomes from the drone data which is added into the scenario, which goes to the 3D scenarios. I'll show the no flooding scenario and 100-meter flood. So this location, I've clicked on one to show the potential flooded data, like potential damage scenario. I'll go to the 100-year flood impact. We can see the 2.5 meter depth of the flood level, and it will actually flow and actually flooded everything in one glance, and will actually shows the information related to the buildings which will actually get flooded according to the flood scenarios. No flood situation. Previously it was no flood, and after getting the flood, everything has been flooded into the situation. The road has been flooded, data should be added, and the outcomes will be in a point cloud format. So you will see the shadow even. So this will be the newest functionality of ArcGIS, ArcHydro, and even ArcHydro scenarios. Final tab will be what exactly ArcHydro provides and what exactly the ArcGIS Pro newest version provides. So we have ribbon tabs. Here you will see the scenario related to project, map, insert, analysis, everything in one glass, and ArcHydro tools, where you can delineate the point, create the flow path, stormwater delineation, and ArcHydro tools even. I'll move towards, and even we have ArcHydro and ArcHydro ground and ArcSWIC. We'll keep the information and we'll show those things related to the Pro extension which ArcGIS provides, like the spatial analyst, network analyst, 3D analyst, data management tools, geostatistical analyst, lots and lots of tools in one glance. So everything can be bundled in ArcGIS Pro and can be usable for the user specific scenario, and individuals can take it for their own analysis and they can create their own beautiful models. Thank you for taking your time. I'll just move my things to my demonstration part has been over. I move to this to Sunit sir to have the further clarifications. Thank you.
So what you have seen is ArcGIS Pro, which is evolved with ArcHydro as a tool, which is primarily addresses the engineering GIS aspect, which is primarily work for water resource department workflow, and has an immense potential for upcoming national water programs like National Hydrology Project, which is an advanced form. And as we're moving further, I would like to showcase is the future of maps was there when it is started as a GIS. I'm talking about ArcInfo as a series story. The future of ArcInfo emerged as ArcMap in 1999. And when it has been there after 25 or some years, ArcMap was there, and it now in 2015 it turned out to be the ArcGIS Pro, which has an immense capability, foundational functionality to cater the water resource department needs and demands. And that's how the things are evolved. And this ArcGIS Pro brings in the ArcHydro as a tool capability. And this is where, if we embrace the change, this is what the change we can get it into. The future belongs to those who invest today. And this is where the urge is. The ArcMap, the earlier version, is retiring in early 2026 by March. And ArcGIS Pro is where the new feature, which has a 64-bit performance applications, advanced 3D and web analytical capability. At the same time, it increases the processing speed as the hardware IT system is evolving. The near real-time data are coming into the forum for visualization, for analysis, and functionality for these national programs, which is coming. So, as we're moving further, I would like to summarize what we've seen in this entire webinar is a hydro feature extraction process refinement tool. It involves, like, data is not perfect, so it involves the interpretation and iterative processing to create the most finished feature extraction. Then linear feature, there is a referencing and dynamic segmentation. What it brings is normally we do the point-based referencing, whereas rivers, channels, canals, we need a linear referencing, and that's what linear referencing bring it to the table. Third, the RAS Commander. I myself is excited when RAS Commander, which brings imported 2D data of structures, results of RAS HDF files directly into the database as well as the Pro project, along with our 1D and 2D geometry extraction. And after processing, which can also create the scenario which is done in ACRAS back to the ArcGIS for the dissemination of information for political master, create what Neha showed, where the indentation map would be, where the velocity would be higher, where the water surface elevations are appropriate as per 100-year return period, 10-year return period, where the drainage systems are having the bottlenecks, where the 1D, 2D geometric extraction from the sewerage network and the drainage network can meet to create the model for tomorrow and make our urban spaces safer. So current is the sustainability does not mean that do the less, but take the most informed decisions of today for a good. And that's what the RAS Commander bring to protect our livelihood, bringing infrastructure to function for tomorrow. Further, the fourth one, what we show is the erosion tool set. It uses the universal soil loss equation rules, which is a revised one, and all this engineering capability you can with the data, you can create the erosion modeling. And then fifth and finally is a 3D simulation, flood modeling simulations. So what the engineering modeling tool of hydrology, you integrate this modeling back into the GIS tool. And from here, the federated structure, you can pass on this information across the organization to do the intervention, map the intervention, create the hazard map, vulnerability assessment, and exposure maps for the various hazards to this kind of applications. And that's what, it's possible with this tool. And one of the, as a last bit, I'm tell you, this is visible in current ArcGIS Pro. As technology is evolving, let's embrace the changes which will bring the assurance for tomorrow that what we're doing with, with more confident and achievable in nature. So thank you so much for your time, and we look forward to our further engagement. You reach out to us as going towards the next journey of a couple of hydrology projects, national hydrology projects, state SWICs are coming up. A lot of water interlinking of projects there. And trust me, this tool will help you not in a format of isolation of desktop, but also infer and disseminate the information across the enterprise level, bring that data from the dynamic level to the field, to the enterprise system, and curate the system of tomorrow, of system as a platform as GIS. So thank you. You may scan this QR code to schedule our one-to-one discussion where how the Esri could, entire our Esri team would help you to contribute to your state, to your department, to your region, to make this nation, our region, the water secure, which is economically viable in nature, environmentally sustainable, and further the socially equitable. So thank you for your time.